Okay, let's work 7.51. Give all possible m sub l values for each case. So we need to give all of the possible magnetic quantum numbers for each of the following cases. Now, to do this, you just have to follow the rules, right? Which we talked about in the last problem they're given in the book. So for instance, for A, I need to figure out how many possible m sub l are possible. I basically just follow the rules. So it's minus L to positive L using all energies in between inclusive of 0. Okay? So it looks like to me, if I go to minus L, since L is 2, it's minus 2, minus 1, I include 0, plus 1, plus 2. There are 5 possibilities there. Okay? Now what about B? Now in B, they give us n equals 1. That's the principal quantum number. Way up at the top here, it's the first one. How many possible m sub l's are there available for n equals 1? Well, we got to kind of go through this sequence here. The first thing we got to do is assign possible angular momentum quantum numbers. Now, if n is equal to 1, the rule for the angular momentum is you start at 0 and increase to n minus 1 using integers. Now, since n is 1, 1 minus 1 is 0, but it seems like the only possibility here for L is also a big fat 0. If that's the case, then I could follow my rule for m sub L, which says to go from minus L to positive L inclusive of 0. And quickly realize that the only possibility there is my 0. So in my n equals 1 level, the only possible orbital is the 1s. Okay, there's only one possible if n is equal to 1 for my magnetic quantum number. Okay, I've got one subtype of S. All right, now C. Oh, this one's going to be more fun because here n is equal to 4. Okay, so if n is equal to 4, this opens up more possibilities for L. Because remember, L can proceed from 0 using integers all the way up to n minus 1. N is 4, so 3 is a possibility. 0, 1, 2, 3 is my possible L's. Now, we want to know about all the possible m sub L's for this level. Okay? Let's think about that some. Okay? My possible values for, or addresses for m sub L are minus L all the way up to positive L. Okay? So, if this L was 0, 0 would be my only possibility. And of course, that's my s-type orbital. There's only one s-type orbital per principal quantum number. Well, what about if L is 1? Well, that's going to be my p-type orbital. But let's take a look at how many possible magnetic quantum numbers exist. Well, if this is 1, I could do minus 1, I could do 0, or I could do a plus 1. So there's 3 p-type orbitals in each principal quantum number or level. I could also have L is equal to 2. If that's the case, I could do a, oops, start with the minus. I could do a minus 2, minus 1 is 0, plus 1, or plus 2. There are 5 possibilities. Those are my d-type orbitals. But I'm not finished because L could possibly be 3. And if that's the case, well, I have a minus 3, a minus 2, a minus 1, a 0, plus 1, a plus 2, plus 3. That's 1, 2, 3, 4, 5, 6, 7. Call those the f-type orbitals. Okay? So if we want to know how many possible m sub L values, right, that could possibly exist for each case, there's kind of a lot for the n equals 4. I mean, it looks like I've got 1 here. That makes 4 when I add these 3. I add 5 more, that makes 9. And then 7 more. It looks like there's 16. So for part C, there's 16, okay? All right, now the last one at least specifies things a little bit more exactly because it tells us that L is equal to 3. All right, so L, the angular momentum quantum number, is equal to 3. Now, if that's the case, what are my possible values for M sub L? Well, minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3. Because I'm allowed to go from negative L to positive L, right? So that's 1, 2, 3, 4, 5, 6, 7. So there are 7 possibilities for M sub L when L is equal to 3. And of course, this would correspond to the F-type atomic orbital that we already considered. All right, so hopefully you're getting a hang of how to connect SPDF notation with this business of angular momentum quantum number, magnetic quantum number, and basically what that indicates or what that means. That's an important concept here for this particular chapter.